Hello, hello everyone. This is Basanta Mahato from Department of Electronics and Communication Engineering, IIMT College of Engineering, Greater Noida. So my today's lecture topic is on various modulation technique in communication engineering. So I am discussing here only on the basis of analog communication systems. So under analog communication system, what are the various modulation technique used? Modulation technique used that I will discuss over here. So as we know, modulation means the intermixing of message signal. Message means the signal which is to be transmitted to the receiver end. And message and the carrier. Carrier means since the message is weak, so the carrier is needed to protect the signal and it carry over the message, and through propagation it transferred to the receiver end. So that is there. But through this modulation process, what ways the carrier changes its shape, that is based on this different type of modulation. So that we will discuss here. So let me start with what are the elements, what are the individual blocks. So communication means it is the process of conveying, transferring information from one point to the another, or it is the process of establishing connections or link between 2 points, that through the transmitter and the receiver. That means transmitter is the source through which the message to be transmitted and to the receiver, which is called the destination. So the first block is to information source and the transmitter. Transmitter is mostly the antenna probably, and through which the signal goes, and in between the channel. Channel means propagating the message. So it might be through the wire, if it is a wired communication, or if it is a wireless, then air. And the receiver receives the signal. Again, receiver is the receiver antenna is there, and that is directly transferred to the destination. Destination means the end. So it might be, it could be mic or some sort of television or the broadcasting system. And through which, since these two receiver destination and the source information, these are the separate block or the system. So the noise may not be introduced in this place, since the channel is open for all. Because in a, suppose it's a wire, the in between the wire may be some noise or some leakage on the channel on the wire. So maybe some noise may be introduced. Or if it is a wireless, so maximum chance of noise to be introduced in between the modulated signal, right? So that's why we write it here, the noise source. Next was in element. So the information, the message or the information to be communicated, this is the original signal. And the transmitter, the objective of the transmitter block is to collect the incoming signal message and modify it to a suitable fashion if needed. So that means, what is the purpose of a transmitter or block? I was talking about this is basically the part of an antenna. So that means the information source always in physical quantity. So in the transmitter, it is transferred. So the signal in the transmitter is, here is the physical, and this is EM wave. Through the transmitter, it is EM wave. So the channel is the physical medium which connects to the transmitter and the receiver. So it may be the copper wire, optical fiber like that, waveguide, and the free space or atmosphere, wireless. And the receiver block receive incoming modulation. Here is a signal message information. What is the signal? Signal is basically a physical quantity, varies with time, space, What it varies basically? The amplitude of the signal. What is the quantity of the signal which is propagating? It's an electrical waveform which carries information like m of t is equal to a cos omega t plus phi. A is the amplitude and cos wave, sine wave fashion. Cos means high, low, high, low. It's a since it is a continuous signal, omega t plus phi. So where A is the amplitude, omega, it's omega is the frequency, that is a radian per second, and phi is the phase. So what are a signal are of two types: analog or the continuous signal, another is the digital. When we say analog signal or the continuous signal, whose amplitude is varying with respect to time. If the time goes on, the amplitude of the signal is also varying. That type of signal comes under continuous signal. Digital signal, it's a discrete signal. If the signal contains only two discrete amplitude, then it is called digital signal. With respect to communication, signal are classified based on baseband signal and band pass. Baseband means the bands are limited. So baseband signal, if the signal contains zero frequency or near to zero frequency, it is called baseband. Like voice, audio, video, biomedical signals. So it's in the pitch is very low. Band pass signal. If the signal contains band of frequencies far away from base or zero, it is called band pass signal. AM signal or the FM signal. So information, it contains the message is called the information. So that is there. Yeah. Technological problem. Means any hardware problem might be there in the, what are the limits of communication? So many things are limited under this. Limited in technical problem. If you are communicating to the transmitter and the receiver, and the might be possible the channel is not properly communicated. If the wire breaks or the frequency band is not communicated, at that time technical problem arises. Bandwidth or the noise. So effect of noise can be reduced by providing more bandwidth through this station, but due to this less number of station can be accommodated. And another parameter of the communication systems limitation is signal to noise ratio, SNR. So noise should be low to increase channel capacity, but it is an unavoidable aspect of communication system. Modulation. It's a very important means if the communication engineering means the modulation. So what is communication? It is the intermixing of message signal and the carrier. But how we mix? So under some process must be there. So it is the process of varying characteristic of high frequency carrier. So carrier frequency is always high because it carries the low frequency signal in accordance with the instantaneous value of modulating message or the baseband signal. Since the modulating signal, message signal is low frequency, so that is comes under baseband signal. Or it is a frequency translation technique which converts baseband or low frequency signal to band pass or high frequency signal. So modulation is used in the transmitter. So before transmission, so before goes into the channel, the modulation takes place. Why we do the modulation? To protect the signal, because our message signal is low in nature, low frequency, low amplitude. So it can't travel to the much more, means the longer distance. To make it long, to make it prevent or safe, we need to protect the signal. How we protect? By you to cover through carrier, high frequency carrier. So types of modulation accordingly, continuous wave modulation and the pulse modulation. Continuous wave modulation, again, two types, amplitude modulation and angle modulation. Angle modulation also, angle, since angle represents the frequency as well as the phase. So that's why angle modulation of two types. One is called frequency modulation, another is called phase modulation. So phase modulation, sorry, pulse modulation are of two types. Analog modulation, another is the digital modulation. Analog modulation are of three types: PAM, PWM, PPM. PAM is the pulse amplitude modulation, pulse width modulation, and pulse position modulation. Digital modulation is a pulse code modulation and delta modulation. So these are the basics of the modulation. One is called amplitude modulation. Amplitude of the carrier is, since it is changing the amplitude of the carrier, it is called amplitude modulation. If the frequency is changing in accordance with the message signal, so carrier changes, so that is called frequency modulation. Phase modulation, phase of the carrier varies in accordance with the message, then it is called phase modulation. So what is the benefit or need of the modulation? To reduce the length or height of the antenna for multiplexing. If you are doing many signals to travel through the channel, on that case, the multiplexing is done. If the multiplexing is if we don't do that this modulation technique, then we can't multiplex the signal, because in multiplexing we need to select the particular channel, means the particular message. So we need to do the process is called modulation before transmission. For narrow banding, or to use antenna with single or same length, to reduce noise effect, to avoid equipment limitation, or to reduce the size of the equipment. So here is the amplitude modulation. Here is your amplitude. This is the baseband signal. This is the message actually, and this is the carrier. And now this is your modulated AM signal. This is signal. This is the carrier, and this is varying with in accordance with the message signal. If the carrier signal is CT is equal to AC cos omega CT, where AC is maximum amplitude of the carrier, omega is 2 pi FC, and modulating baseband is this. So the equation will be this: AC cos omega 2 pi, where MA is equal to, M is the modulation index, AM upon AC. So these are the terms. Here you see we are having three terms: first, second, and the third. First term is AC cos omega TC, so which is free from any message signal, which is it's a pure carrier. Here in this two, FC plus FM, that means message plus carrier, both signal having message. So in the first term, carrier signal with amplitude, so which is free from message, first one. And the second term, mu C upon mu AC upon 2, and frequency FC plus FM, this is the upper sideband, and the third term is the FC minus FM, sideband, lower sideband. You see, so in the frequency domain represents, if we represent the AM signal, what is that? This is the minus omega plus omega. This is the frequency band. So if we remove this signal, so in the so in this case, that means if we check about this, the first term, if we remove this term, that means nothing will affect our modulated signal, because this term is simply carries the only carry the carrier frequency, carrier signal. If we remove this, that means our modulated signal not much more affected. So before transmission, if we suppress this signal, so it will not only it will affect our signal, but also efficiency gets increased. So modulation index, what is modulation index? MA is equal to maximum amplitude of AM upon AC, amplitude of the modulating signal upon carrier, amplitude of the carrier. So percentage index into 10. So time, what are the types of modulation index? If it is 100%, that means it's a critical modulation, MA. That means AM is equal to AC. If AM is greater than this, MA is less than 1, that means under modulation. Over modulation is MA is greater than M. This is that. Under modulation is like this. Under modulation, critical modulation, so-called 100%. Here you see 100% modulated. So now in AM and AC, the value is same. Here the value is not exactly the same. And MA is greater than this, that means some overlap portion is there. So then how we modulate, actually design the modulation, what is the circuitry involved to make it modulation? So here we're talking about till now the theoretical part. So what kind of circuitry is there to do this? The square law modulator is there. This circuit consists of a nonlinear device, band pass filter, and carrier source and the modulating signal. Here is the circuit. In this carrier and modulation signal, these are passed to the nonlinear device, and this is passed on to the transformer side, and this is V output. You will receive that through RL. You will get the, this is a tuned circuit, tuned to FC. So modulation or the detection is the process of recovering the, in the previous one we are talking about the modulator, which is modulated. That's so through output it is transmitted. But at the demodulator case, detector is the process to receive the modulated signal. So the modulated signal pass it to the detector. And after detection, it detects the signal and recover the original signal. So how many AM detectors are there for the demodulator? One is called square law detector, envelope detector, and rectifier detector. Okay. Next, here is a double sideband suppressed carrier, DSB-SC. So if it, after transmission, we have to select what kind of, what type of signal we can transmit. So if we talk about the actual signal, AM wave signal, so this is S of t is equal to AC cos omega this. So you are having three parts. So initially I was talking about this term is only omega c. And this two term having the message carrier, message and the carrier. That means this term we can suppress. But initially, if we transfer this complete signal, double sideband suppress carrier, if we suppress the carrier, what will happen? Therefore, if the carrier is separate, only sideband remains in the required low power. Because it also consumes the power. Our purpose is to transmit the signal with low power, less power. In that case, the efficiency gets increased. And much more, maximum power throw is there. So in power saving in case of DSB-SC is around 66.67. And the next one is angle modulation. Angle modulation is the two type, frequency modulation and the phase modulation. So in case of frequency modulation, carrier according to the instantaneous value of modulating signal. So relation between angle and the frequency is this is. Frequency modulation convert input voltage in the frequency. That is amplitude of the modulating signal changes to frequency at the output. You see, if the signal wave, here is the plus positive cycle and the negative cycle. The moment it changes the negative cycle, the frequency of the carrier, changes, since it is a frequency modulation. You see, here is the frequency is different. The moment is pass it to the negative half cycle, the frequency varies. So similarly, like this. So this is the actual phase of. So these are the mathematical equation for this. And the next one is to then phase modulation. The process of varying the phase of the carrier in accordance with the instantaneous value of the modulating signal. And the phase. So phase means only the phase term we are changing. So in the modulation index for this frequency modulation is the frequency deviation, how much with modulating frequency. So in FM modulation index, if it is greater, then modulation index decides it under bandwidth of the FM wave and number of sideband in the FM. So the modulation index corresponding to the maximum deviation and maximum modulating frequency is called deviation ratio. How much it is deviated. And this is the percentage. These are the mathematical representation of FM wave. It is a signal and the phi m is the message. If it is, and this is the carrier. If we talk about FM wave, then it F is equal to FC 1 plus minus KEM. F is equal to F of C plus minus KEM plus F. So if it is like that, yes, ideal frequency spectrum is this. This is the FC plus FM. So FM frequency is the band difference. FM, 2 FM, 3 FM, like that. And in the negative half cycle, like this. So how many side bands? Infinity. Ideally infinity. So bandwidth is infinity in the ideal case. What is the bandwidth? The bandwidth from frequency spectrum of FM wave in the figure itself. We can say that the bandwidth of an FM wave is infinite. But practically it is calculated that how many side bands have significant amplitude, which have the amplitude lastly. So that will comes under the band. The simplest formula is the bandwidth is equal to 2 times FM maximum into number of significant sidebands. With the increase in modulation index, the number of significant sideband increases. So the bandwidth also increases. The second method is called the Carson rule. Carson rule what? Carson rule states that bandwidth of the FM is twice the sum of deviation plus highest modulating frequency. 2 into delta plus F of F maximum. Highest order sideband is to be found from the next table. After the calculation of modulation index where M is equal to delta upon. If M is equal to this, from the table, modulation index is 4. Highest order sideband is the 7. Therefore, bandwidth is equal to. So these are the mathematical calculations. So type of frequency modulation is, one is called narrow band FM and wide band FM. Why it is so? Because when modulation index is small and when modulation index is larger, on that case is that. So this is directly related to the bandwidth frequency. So comparison between the narrow band and wide band. What are the parameters? Modulation index, maximum deviation, it is less. So narrow band, and the under wide band, it's greater than 1, 75, 25 to the larger than the application. This the representation of this under time band and the frequency domain is this. Okay. Pre-emphasis and de-emphasis. Pre-emphasis is used at the transmitter and de-emphasis at the receiver. It is the pre-emphasis and de-emphasis circuit are used only in the frequency modulation. In FM, the noise has a greater effect on the higher modulating frequency. This effect can be reduced with the help of modulation index for higher modulating frequency. This can be done by increasing the deviation, that is delta. Delta can be increased by increasing the amplitude of the modulating signal at high frequency. So that means, what is the definition of pre-emphasis? The artificial boosting of higher audio modulating frequency in accordance with pre-arranged response curve is called pre-emphasis. We are before modulation, we boost this signal, modulating signal, and de-emphasis the reverse of that. Since how much boost is at the transmitter end, at the receiver end, before the demodulator, we de-emphasize the circuit. So artificial boosting of the higher modulating frequency in the process of pre-emphasis is nullified at the receiver end by the process is called de-emphasis. These are the difference between. So pre-emphasis is the high pass filter and de-emphasis is low pass. Boosting of higher frequency, yeah, removing of high frequency. Used at FM transmitter, yeah, FM is. Now it is a comparison between AM and FM. It is bandwidth is equal to 2 FM. Here is 2 plus delta. Right? So FM generator is there, direct method and the indirect method. In FM transmitter, Armstrong method is applied. What are the advantages? So advantages of FM is the transmitted power remains constant, and FM receiver are immune to noise and good capture effect is the FM. Okay, but a disadvantage, greater disadvantage of FM are use too much spectrum space. Bandwidth is too much. Bandwidth is wider. And application of FM is that is radio broadcasting, sound transmission in the TV, and the police wireless. Then come to the frequency division multiplexing. So frequency is divided. The allocation of different frequency band carrier a different at the. Why we do that? This is possible only because of the modulation. Then only this. So FDM multiplexer, frequency division multiplexer. Different carrier frequency are used at different station of the channel. Modulation is used in the transmitter bandwidth of the FDM. The frequency FDM. Now comes to the noise. It's a very important topic in any communication system. Unwanted signal, which is called noise. Noise are of two types. One is called external, another is called the internal. Internal is coming from the circuitry itself, and the external noise are the atmospheric noise, industrial noise, or extraterrestrial noise. Extraterrestrial noise. Extra outside is the atmosphere noise, radio noise. Suppose we are doing the communication and the nearby some signal is also transmitting. Like, so that maybe that signal interfere in our nearby signal. So that is called under atmosphere. Extraterrestrial noise, that means radio disturbance from source other than those related to the earth. That means the different rays, atmospheric rays are comes into picture. Cosmic noise and the solar noise. Industrial noise, switch gear and the device. Internal noise are the shoot noise, thermal noise, Johnson noise. If our the device we are using maybe it hot, so it radiates some signal. So that radiation comes also included into our message signal, and that will incorporate in the signal. So noise temperature and noise figure. Noise temperature is T, and the noise figure, it is the how much noise is there. So that is represented by the noise figure. It is the ratio of the output and the input noise of an amplifier or the network. So communication model for the noise calculation. Analog. This is the pulse modulation. Pulse modulation two types: pulse amplitude modulation and the pulse time modulation. In pulse time modulation, PM, pulse time modulation, pulse amplitude modulation, in accordance with the modulating signal. Amplitude of the pulse of the carriers is changing. These are the shape. First we sample the signal, sample and hold circuit, through which we do it, and then PM generate. This is that PM. Waveform is transferred like the pulse. Advantage and disadvantage. It's the simple process of modulation. Disadvantage, bandwidth requirement is high, and power requirement is high. Sampling, it is the process of converting continuous time signal into discrete time signal. Are called sampling. Sampling theorem, we follow the Nyquist rate and Nyquist interval. Fs is equal to 2 Fm. So nature of sampling, flat top, another is called the natural sampling. Pulse width modulation, width of the pulse of the carrier is varied in accordance with the amplitude of the modulating signal. That is right. So this is the PWM generator. And pulse position, modulation technique in which position of the pulse carrier train is varied in accordance with the amplitude of the modulating signal. PPM generation, here is the PPM generation. You see, if the pulse is becoming decreasing, pulse is changing in accordance with the position is shifted. You see the position is moving. So this is the PPM, pulse position changing. Detection, information source. So these are, I was talking about the information and the capacity. So this all about are comes under communication systems. So here we here our my topic ends here. But before that, let me so brief about the points I covered here is to what I covered here is the modulation in the types of modulation we are discussing here. The modulation, amplitude modulation we discuss here, and the angle modulation, frequency modulation, and the phase modulation we discuss. Under analog modulation, PM, PWM, PPM. We discussed the modulation technique at the transmitter end and at the receiver end. At the same time, demodulation also discussed. In the later section, we will cover in detailing. Okay, with this, thank you.